So really this talk came from me thinking of a great talk title, Dude, Where's My State File? I mean, anyone who's worked in infrastructure as code knows this is hilarious. So then I had to build a talk around it. And I also love talking about when things go wrong and learning from them. So that is what we're going to learn all about today. So I'll just get to the agenda. So yes, today we're going to be starting off with a case study to set the scene, a bit about why infrastructure as code is powerful really and how it can be used for good and evil. We're then going to be going through a bit of an overview of infrastructure as code to help everyone set the same playing field. And at this point I might ask the crowd a little bit, how many of you work with infrastructure as code every day or consider yourself pretty proficient in it? Yeah, a good mix. And how about those of you who are pretty new to infrastructure as code, may not have used it or used it, contributed to one repo maybe one time? Who's newer? Oh, excellent, it's a mix. That's exactly what I wanted. So yes, we will the overview will help hopefully put us all on a level playing field. We'll then go through the crux of the talk, which is these infra as code anti-patterns. So what things have I seen done wrong in a lot of places, and some tips to address them. And then we're going to do a nice little wrap-up and summary. So, who am I? I'm obviously Kirsty, as I got introduced. I'm a platform engineer or a cloud engineer. I've got both listed there, which fits. Currently working at Upbank. Currently working at Ferocia, and we do Upbank, and we're also owned by Bendigo Bank. So I've been working in tech for over 10 years now, and I've spent the last approximately 7 to 8 of those in cloud and DevOps. And I've spent a lot of that time consulting because I love working in different tech teams to solve different sorts of problems, but please don't hold that against me. And I'm also a massive nerd who loves reading Dungeons & Dragons. This was actually me last year at DDD, different hair color, same t-shirt, talking about Dungeons & Dragons and developers. So yes, I love being back at DDD. So without further ado, I'll get into our case study. So this starts in an unexpected place. For some of you who live in the southeast, you may know the classic. It's a lovely cinema in Elstonwick, and this story starts on a date night with my partner. We were going out on a Friday night to see a movie, very cool, and we were walking from dinner to the movies, and he pulls out his phone and sighs, and I was like, oh. I'm like, oh, what is it? And he's like, oh, I just keep getting these emails all week from my super company saying something's wrong with their systems. And I was like, all week, first of all, I was outraged because I was like, how dare you not tell me about an incident? You know I love looking this stuff up and learning it. So he reluctantly showed me the email. An update from UniSuper. Some of you may know where this case study is going. But basically, dear Thomas, you may be aware of a service disruption. We know it's not malicious action or cyber attack, and we're working on it. And so I was like, oh, that seems pretty bad if you've been getting those emails for a week. And took to Google, as you do, and yeah, it was pretty bad. At that point, there was just lots of news articles about it being down. But how bad was it? So their entire membership portal and app were down for over a week in May in 2024. All systems were back online in 2 weeks, which is actually pretty incredible when I tell you what happened, I think. And yeah, over 620,000 members were impacted. So yeah, it was pretty bad. So bad, in fact, that the Google Cloud CEO came out and did a joint statement with UniSuper CEO, which is a pretty big deal considering how big Google is. Yes, the Google Cloud CEO, Thomas Kurian, confirmed the disruption arose from an unprecedented sequence of events whereby an inadvertent misconfiguration during provisioning of UniSuper's private cloud services ultimately resulted in the deletion of UniSuper's private cloud subscription. That sounds bad. It gets worse. UniSuper had duplication in 2 geographies as a protection against outage and loss. Yay, high availability. Oh no. However, when the deletion of UniSuper's private cloud subscription occurred, it caused deletion across both geographies. Yeah, that sucks, hey. And so, still, what actually happened? So, they had their own special Google Cloud VMware Engine cloud thing that Google Cloud actually helped them to deploy. They ran an internal tool, and there was the inadvertent misconfiguration was Google operators leaving a parameter blank. Seems fine, right? This then had the unintended and unknown consequence of defaulting the customer's private cloud to a fixed term with automatic deletion at the end. So I think it was like 12 or 18 months, and then just like everything disappeared. And it wasn't like one of us accidentally like deleting a database and Google can be like, oh, I'll bring it back for you, no worries. Google's like, oh, actually this is really bad, we can't just bring it back for you. And so that was why there was such a long outage. But what can we learn from that, apart from it being like a platform engineer's literal worst nightmare? That whole week I was just like thoughts and prayers with those uni super engineers. So first one, which is a little bit irrelevant to the talk, but a vibe that I've been having chats with people about recently, practice disaster recovery a lot. Now, it depends on the maturity of your organization, how much and how well you can do this, but sometimes it's like, yeah, we moved our cluster from one AZ to another. We have disaster recovered. And sometimes that's not good enough, and it won't give you enough confidence or enough processes when things actually do hit the fan. And so, yeah, do the hard stuff, or at least acknowledge if you're not doing it, and try to do it in the future. Number 2, obviously, and relevant to this talk, important to have all your infrastructure as code. I literally could not imagine a worse nightmare than trying to recreate an entire production environment with ClickOps. Like, so I think that was really key. And I don't think you could really. I've been thinking about it, and in environments where I've been where there has been ClickOps, and you can't. And final lesson, obviously have good infrastructure as code practices. So it's one thing to have stuff as code. It's another thing to do all the good things around it, which we'll be talking about, to help reduce risk of mistakes like this happening, and also help you recover quickly when disaster does strike, because it will. We work in tech. So what is infra as code? Just to help set that baseline. It's simple, and most of us will know this. It's code to define, deploy, update, and destroy your infrastructure. So it's usually config and YAML or JSON, depending on your tooling, or sometimes different other languages. But yes, it's just as code. So instead of clicking around in a cloud console, sort of like these bad boys, to create things like your networks and your databases, you write down all the config and make it repeatable and safe, because we love code as engineers and not clicking. So yeah, some of the benefits, obviously, like I just spoke about, there's speed in being able to, the example at the start, being able to recreate an environment. You wouldn't be able to do that if you had ClickOpsed it. The really only way is do it as code. But then also for lots of little things like updating your networks or deploying a new service or a new network, where there's lots of different bits and pieces that you have, having it as code and speeds that up so much. It's obviously much safer. You can review your changes. You have audit trails. You have tests. All the good things we know come from code, like writing software as well. It's a really good form of forced documentation as well. When I've been in organizations where ClickOps has been prevalent, even if not intended, it's really hard to have confidence in what's running in production. Like, what firewall rules do we have? What configured services set up with? And so by having this all in code, it's just there in the repo. You can also it helps with the reuse of resources, things like I spoke about it, like helping speed up as well. So often you won't just be deploying one little cloud resource, you'll be deploying a whole bunch. Like a network is a lot of different types of resources. And so being able to group them together and deploy them all at once makes your code much more reusable. And this also leads into self-service. So as cloud more and more moves towards platform territory, depending on your organization, you may not be, as a cloud or platform engineer, doing all of the infrastructure as code yourself. You may have software developers who are coming and contributing to your repos and all that sort of stuff. So yes, lots of benefits, which I'm sure you're aware of. It's at this point that I want to say I'm going to be talking about Terraform a lot in this talk, just because it's what I've used a lot recently. The sparkles are because I do love it. Doesn't mean it's the best. There's loads of different tools obviously out there. But yes, there are some concepts that will be discussed in this talk that aren't as relevant in other tools, so just wanted to give a heads up. This book was also really good, and I've yoinked some stuff from it, so just chucking it up now. If anyone's interested in sort of getting back to basics with some of the Terraform stuff, it's a really good primer. And at this point, I want to go through a little bit of different types of infrastructure as code tools. So when we think about infrastructure as code, at least when I do, I usually think of tools like Terraform or CloudFormation or CDK. And these are like one type, definitely provisioning tools. But the definition of IAC is quite broad at the start. Code to, help deploy, update, configure your infrastructure. And so I'll quickly go through some of these just because when I came into this space, there's so many different tools and it can be very confusing, and it's good to have a little map of how they fit together sometimes. So obviously the most basic and starter pack of infrastructure as code is ad hoc scripts. And this is just writing, instead of jumping into a, SSHing to a VM or something to run some config, you put it in a script that runs when you start up. The next level up from that is config management tools. So your chefs and your puppets and your Ansibles that sort of take the idea of a script and make it much better. You can test, you can run your config, get your servers set up in the right config using a whole bunch of predefined scripts basically, but it's just managed way better. We then have server templating. So this is different to config management. So instead of config management, you launch all your servers and then set them up once they're running. With server templating, you create you create your image of a server or a container, and it's a snapshot of all of the things you need, like your OS and your software and your files. And this is tools like Docker and Packer, which we're all probably familiar with. We then have orchestration tools. So these help manage our virtual machines and containers once they've been created. So once the server templating tools have helped create them, and they handle things like deployments and checking health and scaling, all that good stuff. And this is tools we all probably know and love: Kubernetes, AWS, ECS. And then finally, this leads us with provisioning tools, which is what I think we all still think of with infrastructure as code. And these, obviously, the previous tools were to help in defining code that runs on servers. Provisioning tools are responsible for creating the servers themselves, as well as everything else around it: your databases, your networks, your load balancers, your caches, etc. Oh yes, I just spoke about that, so I'll skip to the next one. So yes, provisioning tools. This is a really lame-ass metaphor, but we're going to go for it. The provisioning tools are like helping to create the structure of your house and all of the networks around it, like your roads and your water networks. I don't know, man. But you still need stuff to do the inside to help configure the server. That's not what infrastructure as code is really like. That's not what the provisioning tools are good at. So this is why you'll still need to use tools like Docker or orchestration tools like Kubernetes to help run all your bits and bobs. And when I say that, I mean our production applications, of course. So how does Terraform work? It's really cool. I think it's just so simple because there's the three core components are obviously the code that you write with all your config. There is the cloud that you're chatting with, and Terraform is super flexible. You can obviously talk with cloud providers like AWS and GCP and Azure, but you can do your observability providers. There's so many open source stuff, so you can integrate with so many things. So yeah, you've got your code, you've got your provider that you're integrating into with their APIs, and then you've got your state file. And the state file I'll talk a little bit about now because that might be a new concept. But because Terraform is so flexible, it needs to keep track somewhere of all the resources it's creating for you. Keep track of its own state, if you will. And so instead of when we have applications, instead of having something complex and a bit hard to manage like a database, it keeps it really nice and short and simple, often not short because there's a lot of config, but simple in a state file. And so it will literally just be like a text file that keeps track of all of your config and all of the variations of that Terraform has created for you. And Terraform basically is just constantly syncing between your code, what's in the state file, and what's in the cloud. And it's so simple, but it works so well. And I'll talk a little bit more about management of state files because obviously it's important to keep track of that and keep things good, as is allusioned in the title of the talk. One thing I did just want to talk about before we get into the anti-patterns is Terraform modules. So For those of you who know Terraform, you'll know a module is, it's just a way to group related infrastructure resources behind a clear interface so they can be reused consistently. So it's just basically a folder of Terraform code that you can call from elsewhere and have really nice clear inputs. But modules is the main way you reuse code in Terraform, and that's what I'll be talking a little bit about that later. So a bit of a definition info. Okay, now we're getting into the juicy stuff, the anti-patterns. Check your defaults. Who would have thought I'd start with this one after such a great intro? Defaults are really hard to do well. And this isn't like, unfortunately, this isn't going to be one of those things where I'm like, just run a linter and you'll be fine. Because there are different things to consider when you have defaults. But depending on how you use infrastructure as code in your organization, defaults can come from a bunch of different places. So like the cloud APIs or your providers you're integrating with will have their own defaults typically. The tool you're using might have their own defaults on top of that. Usually they just use what's in the cloud, but what's in the provider. And then sometimes, depending on how your organization works and how big you are, you might be like reusing modules that have been written by other teams, and they'll have their own defaults. And these often, especially from an organization level, those are pretty opinionated. So yeah, basically defaults can come from a lot of places, which is a good thing, but sometimes hard to debug. And when you're thinking about defaults, it's hard to get right, and like the idea of sensible defaults in tech is something we talk about a lot. And it's hard to get right because there's so many different lenses. So when you're creating infrastructure, typically you're constantly trading off against things like security and cost and usability. And typically like what the cloud provider defaults will give you is not the most secure option. They'll give you the easiest to get up and going, right? Because that's what their goal is. And also depending on if you're reusing modules in the org, depending on what they're optimizing for, like I work at a bank. We care a lot about security, more so than other things. And so we optimize our reusable code more for that. And it's really, you can really easily get caught out on things like unexpected charges, like things like logs have caught me out many a time, and retention periods. You might have, broader security than you anticipate when you deploy a new service because you haven't set the config up right. But yes, this is why, testing in dev environments and stuff is all very important. So a few examples. This is one that we had at work recently, which was it was a good default, but it wasn't right for us. So we introduced some new flow logs for a new service we were deploying, so like capturing all of the logs of all the network traffic that was flowing through, which was great in dev as we were doing it, but then when we went to prod, it was crazy expensive because there's so much traffic in prod, obviously. And so that sort of stuff, it's not a massive security breach, but over time it's not a massive security problem. It's more about the cost. So over time, little bits like this of your config can catch you out with the defaults that you've got set on things like log retention. This scroll through that is playing is just basic bucket on GCP on Terraform. So basically, there's loads of config there, right? Like, there are so many things you can do with buckets because they're cool and sick, but they're very powerful. But I just wanted, you've got all that config, which we saw, but the only required values to get a bucket up and going are name and location. All the rest are defaulted for you, which is usually great and exactly what you want. Sometimes it's not though. And so, sometimes be aware of that. This next one, I was tossing up whether to include this, and this is a little bit just for me, but you're all gonna have to roll with it. If you've worked with me, you'll know that I came to GCP from AWS, and the thing that confused me the most, and I've even got a mug, which I should have brought, that I made, is the IAM structure. Because I think it's very easy to get confused and do not a good default thing. In GCP projects, there's the idea of an IAM policy that exists at the top level of every project. And this lists what role, it's got a list of roles, and roles in GCP is not what roles is in AWS. Forget that. Forget AWS roles. It is policies in AWS, basically. So it's a list of permissions. And It's got a list of so it's got a list of roles and then who can use those roles. So you can control that document all manually. Like you can manage that in Terraform, but Terraform is like, do not do that. You can lock yourself out. Please do not. And so the real resources you should use are this Google project IAM binding and IAM member. And you're like, oh, which one's a good default? Like they both sort of do the same thing. One's authoritative and one is not. So if you use binding, that means only one person can have that role. So if I gave John DBA admin role or something, now obviously we all know that you won't be assigning individuals to roles because we love IAM things, good IAM things, but that means that no one else can hold that role, which sometimes you want, but rarely do you want that level of control, I believe. So what is really a good default and what you should use is having it as non-authoritative, so having the IAM member. That is how I've linked one of my pet peeves and confusion in GCP to defaults. I hope you enjoyed that segue. So with that, we move into our anti-pattern number 2, which is infrastructure drift. This is when state that is captured in your infrastructure as code tool does not match what's actually in the cloud. So obviously in Terraform, you've got this concept of a state file. But if somebody logs in and makes changes, that state file doesn't know about what's happened in the cloud. And so that is when the infrastructure drift happens. And that is usually, like every time I've encountered this, it's been people driven. I think like config errors can cause this and external systems updates. But usually it's, people logging in to test things or respond to incidents or whatever. But it causes pretty big problems over time if you don't address it. Like there's obviously the big one is security risks. All those benefits we spoke of IAC at the start, your auditability, your documentation, go out the window if it's not accurate. And the thing that I'm most scared about as a cloud engineer is predictability. I want to be able to deploy my infra code and know that the state, know that it's going to respond in the way I expect it to. And if things drift, I can't be guaranteed of that. That can cause bugs and downtime, obviously. So the tools are getting better at managing this. This is the AWS one, is a screenshot from the web because I'm a GCP girly now. But this second one is a Terraform output. It gives you a little warning, objects have changed outside of Terraform, which is good to know. But the real fix to this is stopping the people from making the changes and locking down your production environments, which I think we can all agree is a good thing, but it's sometimes easier said than done. And there's a few things you've got to have in place in order to get to that point. Number one is good pipelines and automation for deployments, which feels obvious, but worthwhile saying. You've also got to have a good way to have break glass access for management or engineers. Sometimes in an incident, if you've got a P1, you want to be able to log in and fix things if you think that is going to be the best way to stop the bleeding. And so having a way to be able to really quickly do that in an incident is super important because the last thing you want is your on-call engineers freaking out because they can't make some changes. And obviously, then if there's changes made long-term, the remediation actions after the incident should be to go and clean it up and get it in your infrastructure as code. There's also sometimes little bits and pieces like usability stuff with production access that doesn't get thought about. So engineers are going to need to be able to access the DB in some way typically. There's always going to be those side edge cases. And so thinking about that when you lock down your production environment is really easy. And there'll be loads of things that come up like that if you do enforce this. But having good observability tools and good infrastructure as code so people can see what's running, see the config that's running, allow engineers and everyone to have visibility into your prod environment without having to log in and click button things. I have to say, that's not an issue where I'm working now. We've got a very locked down prod environment, just in the past. So that is anti-pattern number 2. Moving on to number 3 is bad state management. This is quite a broad heading, but it's in the title of the talk. We got to address it. So I spoke about state earlier, and this is different between tools. So in Terraform, I spoke about having a state file. If you use tools like CloudFormation or CDK, I think GCP has some too. They're not that good. But the cloud provider handles that for you, and you just don't have to think about it. when it's not handled by the cloud provider in Terraform, it's easy if you don't have good things in place to get stuck in manual errors. Like, you're not supposed to edit the file, but if it's not, like, it's easy to get tempted into that if you're new to Terraform. Locking as well, like obviously if you use an application database like Postgres, it does locks, all that stuff for you. If you've got a file like in a repo, it's not going to do that. Terraform does have ways of handling it if it's stored in a bucket, but if you're not handling it well, it doesn't. And secrets as well. Sometimes you might have some secrets or secret-shaped things in your Terraform that you don't want in your repo. I have seen Terraform state files in surprising organizations, not naming names, committed into repos. So, like, it happens. But it shouldn't happen because it's really easy to put it in a bucket. And this is what Terraform tells you to do. And it's very easy. Put it in a bucket and turn on versioning. So versioning means it keeps track of every time the file is changed, you get a log of it. And I've used this a surprising amount of times when we've gotten stuck in weird situations which you don't expect. It's good to know that the Terraform, you've got the file there forever, basically. Other things to consider with state management is, how do I handle all my different environments? So you'll hopefully have a production. You will definitely have a production. What am I saying? And then you'll have a whole bunch of environments in the lead up to production. You don't want them all to be in the same, state file or managed in the same way, because what happens if somebody makes a boo-boo and accidentally takes down prod when they were trying to make a dev change? So I think every organization I've been at does this in a different way. But usually think about segregating, whether it's by different buckets, using Terraform's workspaces option, different folders and buckets. There's all sorts of ways to tackle it, but really just thinking about how it's separate and consistent, and when people or pipelines are applying, they are updating the right file, obviously. And just one other thing, using Terraform has you're likely going to need to share some details between between different Terraform targets, and it depends on how your organization structures their infrastructure, but you don't want to have to share all the config for everything, because there is things like secrets and stuff. And so using outputs, which is a nifty Terraform thing, makes that a lot easier, simpler, and more secure. So we'll move to number 4. This is probably the haziest one, but I really wanted to talk about it. Readability and structure. So we're all engineers. We know reading code is something you do every day, and it's really important. And I think it's especially important in infrastructure and cloud teams, because depending on how your code is managed in your org, developers or people from different teams may be contributing to your repo more than other repos, sort of. So you might have a much broader audience for your infrastructure as code. And so readability and helping people find what they're looking for and make it discoverable is very important. And I found different tools have different risks here. When I was back in my CloudFormation days, typically the pattern you'd see without active refactoring would be these really, we've got a VM and a DB, and then it just blows out. And then a couple of years later, you're like, man, this 2000 line CloudFormation file, all in YAML, is really hard to read, hey. And it becomes risky and hard to make changes. Terraform, obviously there are some similar risks. You can do that in Terraform too if you really want. But one thing, another risk with Terraform is that it's very easy to do a huge amount of abstraction and have really complex, you do really complex things with the functions that Terraform provides. And which is great, because Terraform is really cool in that it can do a lot of stuff that tools like CloudFormation can't do. But if you're not careful, it's that classic thing of, you can be too smart for yourself, and then in the future you don't understand what's happening, or other engineers can't understand what's happening. This is just a pretty, this line, if anyone's developing in JSON, you'll do an infrastructure as code with Terraform, you'll be familiar with this. This is, 750 lines. And this isn't again, just like with code, it's hard to decide what's right and wrong given context, but there are some bad smells that sometimes if you're like, hey, this code is really long and hard to read and I don't understand it, just dig a little and ask some questions. Another great example, there's a story behind this one. I felt like this. So I started at an organization and I was a consultant when I started. I'd always be like, hey, where's your infrastructure as code repos? Where's your pipelines? Let me get the lay of the land. And they were like, yeah, sure. Our apps are deployed. Like, here's the app config that you want in this repo. And I opened that repo and I saw this. And I was like, I can see it's a Kubernetes deployment, which I already knew, but like, where's the rest of it? Like, none of this config that they're subbing in was in the repo. And the developer was like, oh yeah, no, it's okay. That's in another repo. And I was like, cool. And so I went to that other repo and it had some more variables. And I was like, okay, that's good. But like, I still can't find it all. Where's all the config? Like, how many pods are running in prod? And they were like, oh no, there's this other one for default values. Don't even worry. And so, like, for them, they were so used to it and it was just in their mind. But for me as a new person, there wasn't anything in the README. It was very hard to self-discover. I'm like, I'm a smart cloud lady. I do this literally for a job. Like, this shouldn't be that hard. And this is where discoverability is really important. And I'll talk a bit more about that in the next anti-pattern too. This is a recent one. I see a front row giggler here who works with me. So Terraform is great in that it's super flexible, but sometimes where you can get caught out is that it's like easier to do some things in code than it is to do in Terraform. And so you'll be like, yeah, that sounds easy enough. I can think about the flow of that. How do I do that in Terraform? And then you get to Terraform and you're like, I'm going to lose my goddamn mind because this is so complex. But also, like, I really need this data structured in this specific way to do the things I want. And so, again, sometimes it might be necessary, so have lots of comments. Sometimes ask yourself, will future me understand this, or will other people in my team understand this? So yeah, I've given some warnings of like, I think a lot of this is like, what are some bad smells that you should investigate and think, can we make this better? But the good thing is, like, in general, Terraform has some pretty good conventions and style guides and stuff to follow. So, they've got recommendations on consistent file names. The other tip is, which I think is so important, and is the thing that catches us most up in the infrastructure space, is refactoring as your repo grows and not doing it too late. Because that's pretty much when I've done it, is when we've been forced to, because people are scared to make changes because it's like, I've got, thousands of lines and I don't know what it's doing. And another thing to think about, having well-scoped and named modules is really important as you grow, and this is what the refactoring should cover as well. And this could change over time as your organization grows and shifts as well. But yeah, having well-scoped and clearly defined input to modules is it's like the best thing about Terraform. But it's so hard to do well. So it's like, I feel like it's a constant job on that. And repository structure is like, again, no best practice, whatever works. But in some orgs, you may have different repos for different modules, and you may import them. You may have different vars and different repos. I think at the end of the day, think about who your users are and how they're going to find what they need to find. And yeah, make it as simple as possible in your environment. So moving on to my final anti-pattern, confusing config. So this obviously links quite a lot into readability and structure, because there's a lot of infrastructure as code pretty much just is config, but I'll break it down a little bit more. So I'm really focusing on how environment and app config is passed through your infrastructure as code. And just like everything, there's lots of different ways of handling it. And think about what your setup is in your organization. So some more red flags. One place I was at, I wanted to add an envar for an application, and I had to add it in 8 different files, and I died. And people were like, no, this is just standard. What do you mean? And I was like, excuse me? And flowing on from this, some bad smells. If teams don't know where their config lives, like if app developers don't know how to find what what envars they're running with, and if it's easy to get confused between what's in non-prod and prod environments, I think people should just be able to find what they need easily. And so at this point I do want to focus on sort of the different types of config, because they should be handled a bit differently, I think, and there's different audiences. So you've got your infrastructure config, and I think of this about like what changes for each environment. So like your cluster size or your DB size or how many pods you're running, whether an endpoint's public or private, like things that will change from dev to prod is sort of, I think, of the infrastructure config, obviously aside from like just infrastructure as code. You've also got app config that can be managed, is typically managed with infrastructure as code or alongside, depending on your setup. And this is runtime specific config, like your envars and config files and stuff that gets mounted. And usually like the development teams are more across and are in control of. And lastly, this isn't really config, but it's a separate thing, secrets. Don't put them in repos. Even in infra as code repos, still bad. We should all be using external secrets managers, like all the clouds have one. But yes, thinking about it's often application specific, and so it's just like another layer of things to manage in different environments to consider. I wish I had like a golden key for like, this is how you do good config, but it's not like that, because every like apps are different, environments are different. Things that can really help make it simple, well-built modules. I didn't put a dot point there, never mind. Think about how simple and easy it is for people to start a new module. Like if you've got really clear, well-named variables, like it exposes all the information that people need to know about what resources are being deployed, and it just makes it so much easier. And again, they've got to be well scoped. If they're too big and deploy too much, people might have like unexpected infrastructure resources being created, and if it's too small and you've got to like have a lot of modules to deploy a thing, it's just like, why are you using modules? So it's hard to do well, but when you do, it's really nice. Structured variables can help with this as well in Terraform. This is just like an input style, but I think thinking about how things are named and what format you feed things in and the hierarchy of stuff, when you're using it, it does help you understand how input values are being used. And so I think, especially in larger organizations where you've got lots of people using your modules, being really focused on what that input looks like is really undervalued and can help with a lot of the understanding of how the module works. And yes, config is easily discoverable. I think this is something I'm really passionate about, but it's really hard to do well, because again, it's those levels of abstraction. You want people to be able to find what they're looking for without getting confused and having to read through like your entire cluster module to understand what they need to for their app. So, in summary, infrastructure as code is obviously great. There's no real alternative now. If you're ClickOpsing stuff, get out of here or talk to me. But with great power comes great responsibility. Obviously, if you're deploying your entire production environment as infrastructure as code, as we learned from our case study at the start, you have the power to completely destroy your production environment as well. And so we should be using all of the good things we've learned from software engineering, like testing and having, good development environments and reviewing each other's code is really important, but then also being aware of the anti-patterns we discussed. So checking what your default config is, managing infrastructure drift, storing your state in a good place like a bucket and having good processes around updating it, having as readable code as you can, and then also trying to make your config as simple for people to find and understand as possible. And I think it's good for all engineers to understand. I was speaking with a group in the front in the start, but infrastructure as code, if you're passionate about it, is something like, I just think it's so cool and powerful. Everything runs in the cloud. Most things we're working on run in the cloud these days. And so having a better understanding of the architecture of that is super powerful for all of us. And infrastructure as code is a really good way to build that. And so I think that's pretty much my summary. I'm really glad that I got you all in a room. None of us were accidentally in the wedding, unless there were, so good job us. Happy couple out there, I'm sure. But yes, thank you also to the sponsors for today who always make, DDD is always such a great conference. And bingo, go do the sponsor things and get your bingo card. Everdel's a great game. And that's it, thanks everyone.
Okay, thank you, Kirsty. So, horror stories were delivered, and many of you can relate to it. I heard there's a laughter going on, which is good. Well done. So before we go to questions, we have a few minutes for questions. Just if you leave in, please leave through the back door and be quiet because we do have the wedding there. Okay, so now questions.
Thank you for your talk. When you were talking about defaults, you mentioned that it's something that linters can't really help you with in terms of motivations for security or cost, but they can be helpful. Do you have any preferred linters or tools that you recommend for people? Yeah,
it's so dependent on the tools that you use. Like TF-lint is like the default basic good one that I use a lot for Terraform, but there is a lot, it'll depend on the infrastructure as code tools you use. But yes, I didn't mean to diss lints, always great, such a low cost way to get some quick feedback in your infrastructure as code.
You mentioned at the end testing as being a really good way of controlling the output here. What does that look like in an infrastructure as code environment as opposed to the unit testing that you might come from as a software engineer?
It's a really good question. And it's so dependent on the environment that the organization I've been in. So most of the time you can do unit testing on infrastructure as code, and some organizations do this, which can be useful for things like some of the security policies and stuff, like OPA, like Open Policy Agent can help with some of that stuff. There's also a lot of the security stuff you can build into your modules. It's not testing, but it's enforcing those value checks as well. But there is also things like local stack and local environment stuff, but typically, depending on your environment, often the quick and best way to test stuff is just to deploy. Which is not in safe dev environments. And it depends on the size and structure of your config, of your infrastructure as code environment. But yeah, I think I would say the stand in the teams I've been in is run some basic stuff in the pipeline and deploy. It's hard to get the right level of usefulness with unit tests and OPA sometimes, but when you do, it's really powerful.
My question is more on the introduction of your talk on how Unisuper managed Terraform state badly, and they ended up deleting something across 2 geographical regions. So how do you split a large state in Terraform is what I'm trying to understand over here. So that something like that doesn't happen.
They weren't using Terraform, I don't think. I don't have insight into what they were using, but it was a Google Cloud tool. But yes, basically there's lots of good checks you can build into Terraform and into resources to protect against deletion. Obviously, any production level changes should be run in pipelines and changes reviewed and all that. But there is we've got deletion protection on a bunch of our core resources so that even if someone does try to delete them, they can't, whether it's via Terraform or directly via the cloud.
How do you split a large state? Let's say you started building your project company became too big. Now you want to compartmentalize into different business groups or something like that. So how do you split a large state?
Great question. This is every organization will go through this, and there's lots of different ways to tackle it. Terraform has great support for moving resources between state files, so you can split them up and manage it. From the cloud perspective as well, they'll often be there might be the example of you want to separate your cloud infrastructure as well as your Terraform management. They're sort of 2 different things, but they are obviously very related. And so it's just being super intentional. I think it starts from what would be it's the architecture of your app, and then sort of boil it back down to, okay, if we have different teams running in different accounts or different projects, what does that mean for our resources? Where do they need to sit? How do we want to manage that as Terraform? They should be managed separately probably. And then how do we have that in our code to sort of support that? So yeah, I think like the cloud architecture understanding is always the driver for a lot of these infrastructure as code like refactors and stuff.
Okay, one last question. Last one, quick one.
How do you manage drift? You mentioned about drift before. How do you manage this?
Yeah.
Is it a manual rewrite of the code, or there are some tools that can help you to reconcile this?
Yeah, I think there might be some tools. Typically, where in the organizations where I've had it done, where I've had to manage it, it's been I love just not having to deal with it. That's the best. But when you do, there's obviously the cloud tools are getting better. The infrastructure as code tools are getting better and better at checking state that they manage. But also there's a risk that, for example, if somebody creates a resource that's not in that your infrastructure as code doesn't manage, so they don't edit something, they add a new thing, that might not get picked up by the tools. And so I haven't really looked into it recently, but I'm pretty sure there are tools that sort of help balance that out. But yeah, it's hard. And typically usually when I've seen it done, it's been like reactions to production incidents, or like, I can only test this thing in prod, and so I must edit it there. And then you just like, the amount I've found, like finding like John to remove created 3 months ago. It's like, John, you never removed your testing security group rule. And then manually like going and like changing the state back to what it should be in your, usually a reapply will pick that up and do it for you. If it's an edited resource, the risk is with added resources.